So Dr. Donahue is the CMU Professor of Chemical Engineering, Chemistry, and Public Policy. He is the director of the Steinbrenner Institute for Environmental Education and Research. Thank you so much.
Thank you. All right. Uh-oh. Okay. Thanks. Maybe I'll look down. I brought some talking points. I actually didn't bring slides because as a professor, it's a little too easy to profess, and I speak graph. And I realize that not everyone does speak graph, and so it's very easy to fall into just assuming that people understand graph. And I find slides that have words on them to just be a distraction. Why listen? And so I'm going to try to keep this brief. In fact, I want to turn on a stopwatch because I also once won the Polonius Award. That's a true fact. So I'm just going to use some talking points, also because scientifically we've known most of what we need to know about the problem of climate change for a very long time. And it isn't all that complicated. It's very easy for a scientist to want to say, there we are. No worries. Obviously there's lots of wonderful complexity, and I could geek out about the complexity for a long time. But what you need to know, the essential bits here are not that complicated. And efforts to portray it that way are, in a pithy metaphor, a smokescreen for a lot of things that we really do know. So to the talking points. No quid pro quo. Adam Schiff is a very, no. Okay, I got the right one here. So yes, climate change is happening. This is probably not a surprise to people in the room, but it is true. It's happening now. It is caused by us. And there's essentially no scientific doubt about that. So that's thing one. Any proposition that we don't, oh yeah, we've kind of gone from maybe it is happening, maybe it isn't, to yeah, it's probably happening, but it's natural. There's natural cycles, and that's there are tiny elements of truth in some of those things. But what we're talking about here is caused by human activity. There's no question that we see the signal of climate change, and it's getting warmer at the rate of about 1/4 degree centigrade, 1/4 degree Celsius per decade right now. And it has been observably doing so for essentially my entire lifetime. In other words, the past 50, almost 7 years. But that rate is increasing, and over the past couple of decades, it's been chugging along at 1/4 degree per decade. And I'll talk a little bit about why, but that is irrefutably true. In fact, all of the essential science was described in a report to the National Academy of Sciences by MIT meteorologist Joel Charney in 1979. It's known as the Charney Report to the National Academy of Sciences. And the basic numbers, how much hotter is it going to get for a certain emission of carbon dioxide that are in that report have stood the test of time. So Charney and the other people on that panel understood enough about climate in 1979 to accurately tell us what we needed to know. Now there was much we didn't know back then. We have actually not just been kind of sipping Chardonnay in the universities in the past 40 years, that we've learned a lot and a lot of important things. But the essential features, how much hotter is it going to get for a certain amount of CO2, we have known for 40 years. And this is one where saying, I told you so, is not so fun, but it's true. So, as I said, it's warming at about 1/4 degree per decade right now. And right now it's about 1 degree hotter than it was at the beginning of the Industrial Revolution. So 1750 to climate scientists is sort of the mark of the beginning. But not all that much happened until about 1950. It got a little bit warmer. But the really big deal has happened in the last half of the 20th century and the continuing in the beginning of the 21st century. So, I mean, one of the challenges in communicating this, when you don't see the fires in California or Australia on fire, is that a quarter of a degree, a half a degree C. Okay, it's C, so 9/5 Fahrenheit, right? It's a couple of degrees Fahrenheit, but still, I mean, a couple of degrees. We could have had a discussion about a couple of degrees and setting the thermometer in this room and what people feel comfortable over. Right? So it just doesn't seem like a big deal when people hear those numbers. And that is a challenge. I mean, we do see major consequences, but a couple of degrees centigrade as the average temperature on the planet actually is a really big deal. And so to give you a sense of scale, at the peak of the last ice age, when like Scrat and what's the name of the saber-toothed tiger anyway, when they were running around in the movies, it was about 5 degrees Celsius, 5 to 6 degrees Celsius colder than it is now, or than it was at the beginning of the Industrial Revolution, right? So 5 degrees is an ice age. So when we talk about 2.5 degrees or 2 degrees or 1.5 degrees, we're talking about the better part of half an ice age. And we are well on pace to get 5 degrees hotter. If we do nothing, if we continue in business as usual, we will easily get that much hotter as it is colder in the peak of an ice age. And I think everybody would agree that from what they understand about ice ages, that it was a lot different. So that is a big deal. The global meteorology and global weather is very, very, very different when you have a temperature change like that. So that's a sort of a scale you can carry around. And as you know, you've probably heard 1.5 degrees and 2 degrees as the kind of Paris 2 degrees centigrade being the agreed target, ideally much less than 2 degrees, and maybe 1.5 degrees of warming as being the objective by international agreement. We're already at a degree, right? But those are we'll get there to 1.5 degrees in 2040 at the current rate. We're warming up 1/4 degree per decade. We're already 1 degree hot, 1 degree hotter than we were, and so 20 more years we're there, right? And another 1/2 degree in 20 more years, so 2060. That's at the current rate. And so then comes the most important, actually from the point of view of science and policy, the next thing I'm going to say is the big important thing. The thing about carbon dioxide, and this really, so there are 2 parts to the big important thing. One, it's really all about carbon dioxide. This is a little bit opinion, but it's well grounded. So there are other things. We talk a lot about methane from natural gas extraction. We talk about deforestation. Those things are all important. But fossil carbon dioxide emitted when we burn coal and oil and natural gas that we've pulled out of the ground, and we dump that carbon dioxide into the atmosphere. We call that fossil carbon dioxide because it's got no carbon-14 in it, and it's been in the ground for 200 to 300 million years. And so that stuff and that carbon dioxide is really what drives the whole problem. And the reason is that the effects are essentially permanent. The CO2 stays in the atmosphere more or less forever. There's nuance to that. Some rather large amount goes into the ocean, causes ocean acidification, but at the same time the carbon dioxide is going into the ocean, the heat is too, so the ocean's warming up. And the net effect of that is that the emissions of fossil carbon dioxide cause warming. And that warming will persist for probably about 100,000 years. Not completely sure of that number, but we don't do a lot of 100,000-year economic and social planning, right? So from the point of view of any discussion we're going to have, the effects are permanent of the emissions. So when I say we're getting 1/4 degree warmer per decade, that's at the current rate that we emit fossil carbon dioxide. In other words, if we decide, hey, we don't want to increase emissions anymore, right? We're going to hold them at the current level, which would be a big deal. That'd be a big change. We would continue to get a quarter of a degree hotter every 10 years. And we have plenty of fossil carbon. Known reserves can last us for a couple hundred years. So we can do it. Yes, we can. And we can just get hotter and hotter and hotter. And it's baked in with the emissions, and that's the most important thing to know. So we really do need to decarbonize. And that's why that's an essential part of the Green New Deal. So there's only a few more points to make, and then I think we can start some questions and conversation. Just so you have some numbers, that's every billion tons, every gigaton of carbon that we emit makes it about 1/400th of a degree hotter. 1/400th of a degree. That's really small, but we emit 10 billion tons of carbon every year, 37 billion tons of carbon dioxide, and so that's a 40th of a degree per year, a 10th of a degree per presidential term, to put a little unit on it, and a quarter of a degree per decade. Right? So those turn into big numbers, and that's something worth knowing. One thing I want to touch on, and from what I understand of the essay, I got the bullet points, is that a term that's, in my opinion, really badly understood is so-called feedback loops. I think people hear that and I could demonstrate, but I can't find the speaker. They think of, there it is. If I grabbed this microphone and I stood up next to that speaker, I might drive our AV person crazy, right? Because you squawk, you get the squawk. And I think a lot of people think of that when they think of feedback loops. We're activating feedback loops, and it's going to run away on us, and the sense that we'll hit some tipping point of activation and we can't go back. Almost all of the feedbacks are already happening. They're what I'm using right here. So a feedback is an amplifier. It's gain. By far, the biggest gain, the biggest feedback in the system is when it gets hotter, it gets wetter. So the relative humidity of the atmosphere stays the same, about 80% in the marine boundary layer, as it gets warmer. But that means the absolute amount of water vapor in the air gets bigger, and water vapor, as you might hear, is a very strong greenhouse gas. And so that amplifies, it actually almost triples the effect of the carbon dioxide. But that's a feedback. That doesn't mean it's going to run away. Actually, my father's the guy who figured out that Venus had an ocean 3.5 billion years ago. The sun got brighter, and so long Venus. So that is an example of a runaway greenhouse effect, that the warming associated with the sun getting brighter and early in its evolution overwhelmed the ability of the system of Venus to actually maintain temperature, and that led to a so-called runaway greenhouse and runaway feedback. I am not worried about that. We understand the Venus case very well quantitatively. But the feedbacks that are in this system are right now amplifying the effects that we see. But there are major consequences of the warming, in addition to just saying it's kind of like an ice age. And the most obvious is, in fact, that the ice sheets are melting. And it's not that that's going to happen if we hit some magic temperature. They're melting right now. They've been melting. And in fact, Greenland is probably toast. So Greenland will melt unless we actually do something very dramatic to get carbon dioxide out of the atmosphere. So it's a question of when. And when matters, and there's big scientific uncertainty in that. So it's going to melt probably in about 1,000 years, and that's a long time. But there's some signs that it might melt a lot faster. And when Greenland melts, the sea level is going to go up by about 7 meters, about 20-some feet, right? That's a really big deal. The West Antarctic ice sheet is about the same mass, a little bit less than as Greenland. And again, there's signs that it may melt. And those are things we don't understand as well. The timing is there's some potential for unpleasant surprises in there, and I do worry about that. But for the most part, feedbacks just mean that the Earth system has things that make the effect of the carbon dioxide louder, just like this amplifying system. And they're working, they're in place right now. And they've been in place all the time. We're not really activating them so much. And yes, fires emitting some more carbon dioxide are part of that. And we're getting more fires because it's warmer. And that's accurate. Another thing, than just about the last there, is, again, I say it's fossil carbon. And so the actual effect of changes from deforestation and so-called mid-latitude greening and everything, all what we call net biosphere exchange. So carbon dioxide going to plants or coming from plants because we cut down forests or because we had major forest fires that are the subject of the essay this week. Those are actually a relatively small contributor. I don't mean insignificant, but I mean maybe a part in 5, a part in 10, 15-odd% is our best guess. The fossil carbon emissions are the really big deal. And so everything kind of comes down to that. And it means that on the one hand, emissions from deforestation and things like that, again, there's something that matter, but they're not the overwhelming part of the problem. That's one thing. But another one is that they're not going to save us. If we just sort of say, hey, okay, let's stop cutting down the forests and whatnot and then let the biosphere soak up all the carbon, that's not going to happen. So that's that, and any suggestion that, if we do radical things through large-scale intentional sort of management, and allowing forests to regrow and whatnot, that might have an important effect, but no way, no how is that going to just magically solve the problem. There is no evidence for that in the history. So just to get it a little bit local and then to be a little bit hopeful, locally it gets really hard to say. The more you worry, the global effects are kind of easy. The more and more local you get, predicting what's going to happen in Pittsburgh is hard. But the general idea is that wet places get wetter and dry places get drier, and neither situation is necessarily that good. And the reason wet gets wetter and dry gets drier is actually really simple. To a meteorologist at least, we call it precipitation minus evaporation. The total amount of water that goes up goes down. What goes up must come down. And so places that are generally dry, they're dry because they're losing more water to evaporation than they're gaining from rain. And places that are wet get more rain than they have evaporation. And if you make the system warmer, that just gets amplified. It's one of those gain things. And so drier places like Australia, like the west coast of the United States, they get drier, they get more susceptible to fires, and you have more of them. Wet places, and we're one of them, likely get wetter. So prediction, it's going to get wetter around here. It might be dangerous to be on Washington Boulevard, but the exact consequences are hard to predict. Finally, I will close with what I hope is a somewhat hopeful note, which is there's a report by the McKinsey group, nothing to do with Buttigieg in this case, but it's actually some time ago. They went through and said, geez, what could we do? What are the interventions we can do that would have a significant influence on fossil carbon emissions, CO2 forcing equivalence it's called. And which of those things actually save you money, and which of those things cost you a lot of money, and what set of things do you need to do to actually move the needle a lot, like all the way? And the good news is a lot of those things actually save money. And they're good old things like wearing sweaters, like insulating buildings, like increasing efficiency and all of that. They do a lot of good. Now, a lot of those things, so getting old buildings to renovating HVOC, my God, those are boring things to do, but they're actually pretty effective. But many of them also take some investment. But they will save money. And so one of the really simple things that places can do is invest in those interventions that have a good climate benefit and also are just good to do because they will save you money. And so simple old investment banks and whatnot and funds that are able to fund that, can fund that for municipal buildings, can fund that for housing in in areas that are largely rental, in low-income areas where you know, a shockingly large amount of money is spent on heating and cooling. Those are incredibly effective as a climate intervention, and they're also really important social interventions. So I think that's a fairly good place to stop, and I will. So thank you very much. And you asked me to have some questions prepared, so how do you want to proceed with that?
So yes, so we are almost right on time. It's 5:34. We're going to be having questions and answers and discussion probably until about 5 till 6, when we'll take a brief break. So if you have questions prepared, Neil, that'd be great.
Okay. So then maybe they're just they're seeds, I suppose. But so the three things I thought of that would be seeds for, and then are we going to do question and answer where, do you want me to answer some questions or just to open it up to an open conversation? What's the?
I guess ask those
Yeah.
seeds throughout those
Yeah.
seeds, and Dee will be taking notes.
Okay. It's going to be fun to see the old thought cloud here. So the three things I thought of maybe framing this with are, you know, one, what are your worries, especially for Pittsburgh? You know, so I close by saying, I don't know what's going to happen to Pittsburgh. It's probably going to get wetter. But, you know, as Pittsburghers and Allegheny Countyers, Alleghenians, you know, the question of what are you worried about here is one thing to think about. Because local consequences are what can drive people who aren't us, and also give people agency. And so on the agency side, what do you think you can do, right? Is it political activism, you know, get people to vote, or are there other things you can do personally? So how can you get agency in this, and how do you feel that other people will feel a sense of agency? And then finally, the third one is a little self-serving, but I am pretty good at this. I've spent a lot of time thinking about it. I'm kind of a world expert. So what are there things that you think you don't know that are technical questions that I might be able to answer quickly? Then I'm happy to answer technical questions.
Did you need a reminder of what the second question was?
He talks faster than I do.
Okay.
That's a known issue.
Is the second question, am I understanding it correctly, how can we take agency,
Yeah.
take responsibility, take action in this crisis?
What can you do, and whatever you want to mean by you as in individuals, or we as in a group?
So Brianna's going to be taking stack. If you have your name card, hold it up so she can put you on stack. Is there anyone here who does not have a name card? Raise your hand. Okay, I'm going to get you both name cards, and Brianne is already starting to take names. Who's first, Brianne?
I can't see your name, but
Is that Marcia?
Yep, sorry. So I guess my question is, and it's, and I don't know if you have the answer for it. You might, probably don't.
Marcia, eat the mic.
Oh, eat the mic. Okay, thank you.
Point it at you, not like an ice cream cone.
Okay, like
right
this.
at you. There you go.
Okay, there we go. So, and I guess my question is I know that obviously the federal government subsidizes, you know, CO2 fossil fuels, and that the state does. Do we know if the county subsidizes as well? Subsidizes fossil fuels? Does anyone know that? Because I don't.
Tax increment financing, I think, is that ever done at the county level?
Yeah, it would be whether, I mean, essentially deals, so any development, permitting that gives tax breaks or whatever, but I'm not sure if anyone has looked at the any URA or other development investments as sort of related to net fossil emissions. I have no idea.
Okay, because I just
would
think
be
that might be a
interesting,
place
yeah.
to start was
Yep.
all is if we're going to start local would be to
Right.
see what they're
And
doing.
what you want to do is you'd want to look at the funding agencies that the county has, which are things like the Urban Redevelopment Authority, and look at investments or expenditures that they've made and kind of compare them to carbon footprints or whatever. And I'm not aware that anybody has done that.
Thank you. I have, I guess, 1 point for each number. The first one, the thing I've noticed most in Pittsburgh, like you said, it's going to get wetter. Even this past summer and I guess season, a lot of the crops were struggling because of the high rains we got in the beginning of the season. And I think that's just going to get worse. As far as personal action to do that, I know we're sick of hearing it, but 80% of the crops grown go to feed livestock. So cut down on your meat intake is something that can help, just because if crops keep failing, we're going to have less to eat. And those crops are going to have to go to feed people instead of factory farm animals. And then the question I had for you is, you mentioned the fossil carbon doesn't have any C14. Does that like burn differently or like stay in the atmosphere longer? Like, does it act differently?
No, that was just me being a geeky scientist
Okay.
and pointing out why it's called it. But no, so we use carbon-14 is produced in the atmosphere from essentially, ultimately from cosmic radiation, and so plants take it up because it basically behaves like any other carbon dioxide. If you get really geeky, it's not exactly the same, but that's like way out of the, but because it decays with a, what is it, 5,800 year half-life, I think, we can use it as a clock. And so you can take a sample of a piece of wood from a building or carbon date things. And because coal's been in the ground for 200 or 300 million years, it's got none. And that's all. That's why it's called fossil carbon, because it doesn't have any. And then we made it with a bomb as well, but that's another story. But no, it doesn't behave any differently. Another thing to point out is that, so if there are a whole bunch of things I would do if I were king, but I am certainly a fan of pricing carbon, of putting a large carbon tax. It makes a lot of sense, but one thing that is a hidden source of carbon dioxide, that was it. That's runaway almost. Hey, he's king. He can do it. But it is ammonia. So what's called the Haber-Bosch process, and the whole agricultural revolution fed by fertilizer, every molecule of ammonia, every molecule of urea in fertilizer pretty much is 1.5 molecules of carbon dioxide from methane. And so Qatar and other places that have natural gas, CH4 methane, it's really hard to ship around, but in the Haber-Bosch process that makes ammonia out of nitrogen gas uses methane for the hydrogen to put on the NH3, and it also uses burning methane to make the heat, to heat the catalyst to make it. And so producing fertilizer right now at an industrial scale means fossil carbon emissions. And so if we tax carbon and we put I would do $600 a ton, we are basically going to be taxing fertilizer as well. And that will have huge consequences agriculturally. And it has to be thought through, but people who are fans of organic local agriculture generally would find that favorable because it would disfavor large applications of fertilizer.
It's okay. Hi, so my question is there something that we could be doing, we being on an individual basis, that, I mean, I know you and Maren and you guys have been around and you know what we're doing in terms of what we're doing and in terms of activism. But on an individual, as well as on an individual basis, is there something that we could be doing that we're not doing?
Yeah, and by the way, even though you're well known, introduce yourself, please.
Terry.
Okay, Terry. The trite thing and true is make sure that people vote, and they vote the right way. Because it's an international problem. But what I was alluding to talking about the McKinsey report and efficiency and whatnot, that we could cut our fossil emissions in this country pretty much in half by efficiency improvements. And so the so-called low-hanging fruit that actually makes economic sense anyway in the so-called McKinsey cost curve, anything we do, those ought to be things that you ought to be able to convince people to do anyway. And so that will have, those are the so-called co-benefits. Never mind what I do, which is air pollution, which again, all this fossil carbon combustion makes air pollution. Air pollution kills about 250 people in the county every year. And so things that we do to reduce fossil fuel combustion are indirectly going to be saving those lives, which is a local argument for why to do the things. So I would say economically sensible, cost-saving things like energy efficiency improvements, housing improvements, low-income housing improvements. There are a whole bunch of things that touch multiple issues that I think this community cares about that have a climate benefit, and we ought to focus on those locally.
Neil, over here. I'm Rick Ankeny. My question is, if you were a dictator of the United States and could
I got a red hat here.
and could emulate other countries that have done a better job of getting their carbon emissions under control than we have, I guess which countries would those be, and what are they doing that we should be doing? In other words, are there things that we can, where we don't have to reinvent the wheel, right? The other countries have had some success in making some progress that we could, both locally here and as a country, emulate.
Yes. So I'll give a twofold answer, because if I were king, I wouldn't necessarily do exactly what other countries have done. And I would say not many large countries have done especially well. Some have made commitments. Scotland probably is going to become an independent nation pretty soon, but it's heading toward carbon neutrality. Scotland's got a lot of wind, and a lot of that has to do with wind farming. That's easier when you're little, because it's easy to do if you can essentially just use existing electricity infrastructure in the grid to kind of back up and maintain momentum and phase matching and all of the other kind of geeky things that you have to do to keep electricity going. I would, first of all, put in a carbon tax, $20 a ton per year, increasing until it hits $600 a ton. Was exactly what I would do with that. I would invest in long-range electricity transmission, because we pretty much know how to do that. And the biggest issue with renewable, wind and solar, is so-called intermittency. And some of that is like day and night and seasons, and that's hard to deal with. But some of it is just that it's cloudy for a week, or it's still for a week. And to get away from that, you have to move energy farther than the weather, and that's a couple thousand kilometers. And so a boring infrastructure investment that we really should do is grid improvements. I would electrify existing rail lines, and I would move goods with electric rail. And that's something that Europe certainly does do. So Europe in general, Europeans on average use about 5 kilowatts of energy per person. We use 10. So we use twice the energy for essentially the same standard of living. And a lot of that is it's not that Europe is more compact. It really isn't. It's more compact locally, so there's much more, you have open farmland and high population density centers. We have a lot of urban sprawl. So there's a bunch of boring infrastructure, things like that I would do. But the tax, electrification of rail, and long-range transmission are the 3 boring things I would do.
I just want to speak to your first question, which was our worries about Pittsburgh. I mean, for me, assuming that capitalism continues to be the system we operate in for a while yet, I'm very worried about the infrastructure of Pittsburgh. I think we have to be seriously concerned about that. More rain means more collapse. It means more of a burden on our sewer systems. I can imagine many of the hillsides around Pittsburgh, and that means the roads as well, just kind of collapsing. And then who pays for that? How do we function? Who's going to pay for the massive repairs that would have to be done in a city like Pittsburgh? And they would be massive. You can imagine the number of Route 30 collapses happening around here, Commercial Avenue collapsing, any main thoroughfares actually coming down, and the loss of housing, et cetera, et cetera. Does that mean a massive increase in taxes? And my second comment on that, my fears, is that Pittsburgh remains probably a good place to relocate to when the oceans rise. I mean, how the hell do you operate in New York City when your subway system goes underwater? If you take a look at Pittsburgh, we have water, we have a temperate climate for the most part, we've got a lot of things. What happens to this city? Does that accelerate the expulsion of low-income people from our city? Does it force even more of a housing crunch? And on top of that, what if we eventually have, and we probably should, because it might save our city, international immigration into the city? Will there be racism as if people decide to oppose international immigration coming to the city? Those are a lot of my fears about what will happen and my worries about the future of my city.
Hello, I'm Hadrian. I was wondering, so you said like the planet's not going to become Venus. So I was wondering if you could talk about the line between urgency and hyperbole and where you draw that in regards to like an ecological context, just to clarify for us who aren't experts.
Yeah, and that's the man, I could talk for about 4 hours on that question, so I'll try to pick a few points, because one is a kind of a weird thing, and I'll try to do this quickly. But as an activist, so there is uncertainty. When I said the temperature is going to increase by a tenth of a degree per decade given current emissions, we don't know that number perfectly. It actually could be as high as a fifth, and it could be as low as like it could be as high as not quite a fifth, but a quarter, and it could be as low as maybe a 15th. There's a pretty wide range of uncertainty there, and that's a lot of what we work on. But we had a pretty major study a couple of years ago, and if you worked all the way through it, the consequence of that study was that we made it less likely that climate was very sensitive to emissions of carbon. Less likely, but so, and on the whole, we were saying, yeah, the estimate of how much hotter it will get per gigaton of carbon or whatever is a little bit lower, well within the range of all the uncertainty studies. Almost instantaneously, the Wall Street Journal had an article about how all understanding of climate change is essentially bunk, and it was in May 2016, and actually Trump had a climate speech, an energy speech. Shortly thereafter, it was essentially referring to that. And so, as an activist, you almost want the problem to be worse, right? Which is awfully screwed up. Yeah. But I, when we were even writing that paper, I was like, oh man, this is going to happen. I could dig you up emails that essentially foretold that sequence. And so, yeah, I don't think we're all going to die. I'm sometimes called a Pollyanna for saying that by people who you might know in this room. I think a lot of people might die, so I don't actually regard that as optimistic. But I don't think that we're going to become a Venus. And one way to do it is to try to articulate the costs well within a market economic framework and say that the costs. But there's a paper by a CMU grad named Kate Rickey in Nature Climate that assessed the cost of carbon globally at $400 a ton emission. And everything I've been talking about and all the infrastructure investments we're talking about, which are wonderful to do, cost way less than that. And so there are actually lots of compelling arguments for why we should do this. But actually, yeah, we ought to invest in roads. We ought to actually shore up the hillsides. We ought to do all those things. How do you get people to do that now? and we've been trying to get them to do it now for 40 bloody years. And I'm a little tired of that. And so, it's tempting to say, yeah, if we don't do it now, we're all going to die. But I don't think that's true. But, you know, we are seeing really big deal consequences now. We did have an example 35 years ago with the ozone hole, which, you know, that actually did. I mean, it worked. We fixed it. It's going to take 100 years to actually fix, but we stopped emitting freon and all that stuff. You know why? Ultimately, why? Actually, there are 3 reasons. One is DuPont actually had other refrigerants and they were newer patents, and so they made more bloody money off of the new stuff. That helped. 2 was Reagan and Thatcher's husband both had melanoma. And so when the big old ozone hole showed up and people said that has to do with skin cancer, 2 individuals woke up and said, whoa, I care about that. And they happened to be 2 incredibly powerful individuals. So I do think in the case of climate, it is important to sort of get broad acceptance and everything and talk across the aisle and all that stuff. It's also really important to find really powerful people who are actually going to do what they can to make things happen.
Neil, if I can
Yeah.
interrupt, we have a few people on stack, but we do need to take a break and make way for the speakers that will be addressing possibilities for action, advocacy, things that we can do to address our current system right here in this region. So before we end with Dr. Donahue, for those of you who are still on stack, did you have a question that could only really be answered by Dr. Donahue?
Quick.
Or could you save your question for the second round of discussion after our advocacy organizations speak? So raise your hand if you're on stack already and you have a technical or scientific question that only Dr. Donahue can answer.
Well, I'm Lucy DeBarbaro. I have to speak to the energy efficiency because we are the nonprofit doing energy efficiency for homes. And we know of various programs like from URA within the city. But people can find me $5,000 grants to people who earn less than 80% of area median income, as well as 30-year loans for 0% interest to make improvements. So there are options. But I do have technical question. It has to do with those feedback loops, because I am somewhat worried about the methane release from the melting permafrost and few other. So why do you say that we don't need to worry?
I don't say we don't need to worry, but yes, so to be clear, there are those ecological changes. So the image that methane coming out of permafrost, or for that matter, out of what are called ice hydrates, so-called fire ice, and there's a lot of methane down there. Yes, we should worry about that. My point is that they don't. It's not like all of the methane is going to go blurp out of all of the permafrost all at once. There's a temperature horizon. There's a sort of a permafrost ice zone. Also, it just gets darker when the ice melts. Though what my point is that those things are happening now, and they've been happening for the past 20-odd years, and they will continue to happen as that melts. And so they're part of the process that right now is responsible for it getting 1/10 of a degree hotter per year. They're already in the game. That's my point. Yes, we should worry about them.
We should worry, because they will continue to accelerate the process, right?
Yeah, but they're not likely to make it accelerate essentially out of control. Because the other point is that right now, it's going to stay hotter forever. Did you have
Hi,
one
my
more
name
question?
is
Yeah.
Amanda. I'm an environmental engineering student at Pitt. I'm asking your opinion on nuclear energy as an intermediate solution to before we transition to green energy.
My cop-out thing is that one of the reasons I like putting a price on carbon is that I like to say my job as a climate scientist is to pick the loser. And the loser is emitting fossil carbon into the atmosphere. If I put a $600 a ton price, and I actually won't completely pivot away from your question, I'll answer it a little bit. But one thing that is actually very much on the table is anything that doesn't emit that fossil carbon doesn't get taxed. And so to be clear, if I made a methane generator and I captured all the carbon dioxide from generating that electricity and I capture and sequestration, put it back in the ground, that would be a viable solution. I got a lot of reasons I'm not super comfortable with that, but from a sort of a climate perspective, I'm like, okay, if you can do that, with all the carbon capture and everything else, fine. So my opinion is, with a lot of nuance and uncomfortableness, that existing nuclear plants, I think it's a pretty bad idea to retire them unless we really know why we're doing that. In continuing to build out that infrastructure and sort of next third generation nuclear and whatnot has some intriguing possibilities. I do worry a lot about proliferation, and as a green chemist, which is one of my hats, we're trained to worry about persistent pollutants. Carbon dioxide is a monster persistent pollutant. As I said, it sticks around for 100,000 years. The waste sticks around a long time too, and that's a real concern. But I'm hesitant to rush to retire existing plants.
Thank you so much, Neil. Okay, we're just about 5 minutes behind. So we have about a 5-minute break. Please try to have yourselves back in your seats 5 minutes from now.